What if the entire Earth experienced one full year of continuous rainfall, followed immediately by another year without a single drop? Imagine waking up tomorrow to the sound of rain against your window, and that sound never stopping. Not for days, not for weeks, but for 365 straight days. Then, just as suddenly as it began, the rain stops completely, and the skies remain clear and merciless for another full year. Let's start with that first year of endless rain. Within the first week, you'd notice something unsettling. The ground can't keep up. Most soils can absorb about an inch of water per hour under normal conditions, but after continuous saturation, they lose that capacity entirely. Picture a sponge that's already completely soaked. Every additional drop just runs off. Now multiply that across every surface on Earth. The initial flooding would be catastrophic, but not in the way you might expect. Rivers wouldn't just overflow, they'd fundamentally change character. The Mississippi River, for instance, typically carries about 593,000 cubic feet of water per second. Under continuous global rainfall, that number could increase tenfold. The Amazon, already carrying roughly 209,000 cubic meters per second, would become an inland sea stretching hundreds of miles beyond its current banks. Coastal cities would vanish first, not just from rising seas, but from rivers flowing backward as ocean levels climb faster than they can drain. But here's where it gets really interesting. After about 3 months of continuous rain, the very chemistry of our atmosphere would start to change. Plants, initially thriving in the endless moisture, would begin to drown. Without their root systems processing carbon dioxide effectively, atmospheric CO2 levels would start climbing. Meanwhile, the constant cloud cover would reflect more sunlight back to space, creating a bizarre greenhouse effect trapped beneath a planetary blanket of clouds. 6 months in, we'd witness something unprecedented in human history. The formation of megaliths, where none existed before. The Sahara Desert, receiving its first continuous precipitation in millennia, would become a temporary ocean larger than the Mediterranean Sea. Death Valley, normally 282 feet below sea level, fill completely and then overflow, creating a massive inland sea connecting to the Pacific Ocean through a chain of overflowing basins. The weight of all this water would literally change the shape of our planet. Earth's crust, particularly in areas unused to heavy water loads, would begin to depress. GPS satellites would need constant recalibration as continents shifted under the immense hydraulic pressure. The very rotation of Earth would slow slightly as water redistributed from the poles toward the equator, adding about 1.7 milliseconds to each day. And then, exactly 1 year later, the rain stops. Completely. The transition wouldn't be gradual. One day there's rain, the next day there isn't, and there won't be for another full year. The silence would be deafening. For the first time in a year, humans would hear something other than the constant drumming of precipitation. But that momentary relief would quickly turn to horror as the true scale of what comes next becomes apparent. Within weeks, all that accumulated water would begin its inexorable journey toward the oceans. The temporary lakes in the Sahara would start to shrink, but not gently. Without any new rainfall to replace evaporation, these massive bodies of water would disappear at a rate of several inches per day. The receding water lines would leave behind salt flats larger than entire countries, poisoned with concentrated minerals that would take decades to wash away, if they ever could be. Plant life, having adapted to the previous year's abundance, would face an immediate crisis. Forests that had grown lush and dense would suddenly find their root systems completely inadequate for the new reality. The Amazon rainforest, responsible for producing 20% of the world's oxygen, begin to die from the canopy down. Trees that had grown too quickly in the water-rich environment would lack the deep root structures needed for survival. 3 months into the drought year, the real catastrophe would begin. Rivers that had swollen to unprecedented sizes would shrink to nothing. The Colorado River, already over-allocated in normal times, would simply disappear. Lake Mead and Lake Powell would become desert valleys once again. The Great Lakes, having overflowed their banks just months before, would retreat so far that ships would be stranded miles from any remaining shoreline. Agricultural collapse would be swift and total. Crops planted during the flood year would wither in fields that had turned to concrete hard clay. The topsoil, washed away during the endless rains, would be gone forever. Wheat fields in Kansas, rice paddies in Vietnam, olive groves in Italy, all would become barren wastelands. Food reserves stockpiled during the previous year would dwindle rapidly as the reality set in. There would be no harvest this year, possibly not for many years to come. But here's the most terrifying part: the heat, without cloud cover to reflect sunlight, and without evaporative cooling from plant transpiration. Surface temperatures would soar. Cities that had flooded just months earlier would now bake under relentless sunshine. Asphalt would become molten during midday hours. The urban heat island effect would intensify dramatically as concrete and steel absorbed and retained solar energy with no vegetation to provide cooling relief. Desert regions, ironically, would fare better than temperate zones. Plants and animals in places like the Atacama Desert or the Australian outback are already adapted for extreme drought conditions. But ecosystems that had never experienced such conditions would collapse entirely. The boreal forests of Canada and Siberia would ignite in wildfires, so massive they would be visible from space. As a continuous band of smoke encircling the northern hemisphere, 6 months into the drought, underground aquifers, water sources that took thousands of years to accumulate, would be tapped at unprecedented rates. The Ogalla Aquifer beneath the American Great Plains, already stressed from decades of agricultural use, would drop by hundreds of feet. Wells would run dry across entire continents. Cities would implement water rationing so severe that daily allocations would be measured in cups, not gallons. Ocean levels would begin to drop as evaporation continued without replacement. Coastal areas that had been underwater during the flood year would emerge as mudflats stretching for miles. These newly exposed areas would become salt deserts, inhospitable to any form of life. The changing ocean levels would disrupt currents that regulate global climate, creating feedback loops that would extend the drought's effects far beyond the single year. By month 9 of the drought, something remarkable yet horrifying would become visible from space. Earth would start to look like Mars. Brown and tan would dominate satellite images where green and blue once prevailed. Dust storms, no longer held down by vegetation, would rage across continents. These storms would be so massive they would affect global air travel, grounding flights for weeks at a time as visibility dropped to zero across vast regions. The final months would witness the collapse of civilization as we know it. Power grids dependent on hydroelectric generation would fail as reservoirs emptied. Nuclear power plants would struggle to find sufficient water for cooling. Wind turbines would be damaged by constant sandstorms. Solar panels would become coated with dust, reducing their efficiency to nearly zero. In the end, as year 2 of this nightmare scenario concludes, Earth would be a fundamentally different planet. The lush world that entered the first year of rain would be gone forever, replaced by a scarred landscape of salt flats, empty riverbeds, and dust bowls. Species extinction would occur at rates not seen since the asteroid impact that killed the dinosaurs. Entire ecosystems would exist only in memory. But perhaps most haunting of all would be the silence. No rain, no flowing rivers, no rustling leaves. Just the whisper of wind across endless expanses of barren ground, carrying dust from what once were forests, farms, and thriving communities. The planet would survive this catastrophe as it has survived others throughout its history. But the world we know, the delicate balance that allows 7 billion humans to thrive, would be gone. And somewhere, in the deep quiet of that transformed world, we might finally understand just how precious that gentle, ordinary rhythm of seasonal rainfall really was.